What would happen if we took humanity's most powerful nuclear weapon, the 50-megaton Tsar Bomba, which you can see here towering over this person, and dropped it directly into the deepest point of the ocean? That target is the Mariana Trench, a pitch-black valley on the ocean floor, plunging a staggering 11 kilometers straight down. To put that extreme depth into perspective, it is almost 3 times further down than the resting place of the rusted Titanic shipwreck. You might assume this is a recipe for a global catastrophe. Surely a detonation of this magnitude would trigger hundreds of meters of water to violently crash down on coastal cities. You might even worry that an explosion this deep could rip tectonic plates apart, trigger new volcanoes, or kick the Earth completely out of its orbit. But none of that happens. The reality is that we tend to heavily overestimate our own destructive capabilities, while completely misunderstanding the crushing physics of the deep sea. Let's trigger the detonator. In the first few microseconds, the fuel undergoes a chain reaction, exploding with the power of 50 million tons of TNT and illuminating the pitch-black trench for the first time in history. The intense heat instantly vaporizes the surrounding water, carving out a massive flaming cavity of gas and radioactive nuclei. If this were happening on the surface, the fireball would expand with very little resistance to 10 kilometers wide in a single second. But down here, the rules change because of hydrostatic pressure. Looking at this vertical cross-section of the ocean, you can see how an 11-kilometer column of water overhead exerts an immense weight, creating 1,000 atmospheres of pressure at the seafloor. All that weight acts exactly like a giant hydraulic press. The water pushes forcefully inward from every conceivable angle against the expanding bomb blast. So instead of a rapidly expanding, apocalyptic shockwave, the raw outward energy of the nuclear blast crashes head-on into the overwhelming weight of the ocean above it, trapping the explosion in place. Exactly 1 second after detonation, the nuclear fireball reaches about a kilometer across, and then it stops dead in tracks. This diagram shows the physics at play. As the fiery bubble pushes outward, its internal pressure steadily drops until it is overcome by the external weight of the ocean, which aggressively squeezes it back inward. This kicks off a violent deep-sea tug-of-war. The bubble rapidly shrinks as it recompresses, spikes in internal pressure, and then briefly attempts to expand outward again. It bounces back and forth like this a few times, but ultimately the fiery death bubble loses the fight. The crushing, turbulent water begins chopping up the massive central cavity, tearing it apart into a harmless plume of smaller, warm, radioactive bubbles drifting toward the surface. Humanity's most concentrated burst of destructive energy is completely dismantled by the continuous, unyielding forces of nature. As for the coastal cities, they are completely safe. Because the deep ocean contained the explosive blast so effectively, the surface only sees a small, unremarkable wave. The idea that this would crack the planet's crust is equally false. The surrounding water absorbs the vast majority of the explosive energy, meaning the resulting seismic shockwaves are no stronger than standard, naturally occurring earthquakes. And the planet's orbit? We haven't added or removed any mass from the Earth, so its trajectory through space doesn't budge an inch. The only real damage here is highly localized. Any whales or deep-sea marine life unlucky enough to be swimming near the shockwave will face a tragic end. The radioactive fallout from those rising bubbles will rapidly dilute into the massive Pacific currents, while a small portion enters the atmosphere and eventually precipitates as rain over the open ocean. We view our nuclear weapons as capable of ending the world, largely because they are entirely capable of ending our world. But when forced to directly fight the incredible mass and pressure of the planet itself, humanity's greatest weapon is completely insignificant.